Hello students, welcome back to SapphireBlueChemspark. Let us start our today's session, the chapter D and F block elements. Previous sessions we have discussed about the general characteristics of transition elements, and also we completed one of the important salt of D block elements, that is potassium dichromate. Today we are going to discuss about the another important salt, potassium permanganate. It is the salt of manganese in which the manganese is in +7 oxidation state and the color of the salt is purple color. How do you identify the oxidation state of potassium permanganate? The previous class we discussed for the potassium dichromate, to which the oxidation state of chromium is calculated. Here we can find the sum of oxidation state of all the elements should always be equal to 0 when it is a compound. So here I have 1 potassium, so I can write 1 into +1. Plus manganese I am going to find out, so +6. Oxygen 4 times, so 4, and each oxygen whose oxidation state is -2, this is equal to 0. 4 2s are 8, -8 plus 1 -7, so x minus 7 equal to 0 or x equal to +7. So the oxidation state of manganese in potassium permanganate is +7, and this is what its highest oxidation state also. Then preparation of potassium permanganate. Potassium permanganate is actually prepared from pyrolusite ore. Pyrolusite is nothing but manganese 4 oxide. In this manganese it is in +4 oxidation state. So this is called manganese 4 oxide or usually manganese dioxide. So when this pyrolusite ore is fused with potassium hydroxide in presence of either atmospheric oxygen or any other oxidizing agents like potassium nitrate or even potassium chlorate. Potassium nitrate, potassium chlorate, both of them are strong oxidizing agent. The fusion of potassium hydroxide with the pyrolusite mineral that can be oxidized by either atmospheric oxygen or by potassium nitrate or by potassium chlorate. So upon heating this mixture, pyrolusite ore is converted into potassium manganate, in which the oxidation state of manganese is +6. So you have to balance the equation 4 to 6. There is increase in oxidation number. So we can say loss of 2 electron over there. And in oxygen this is 0. 0 to water we have, that is -2. So oxygen has gained 2 electron. How many oxygen I have? 2 oxygen. So it has gain of 2 into 2 electron. So gain of 2 into 2 electron, that makes it is equal to 4 electron. But manganese can give 2 electron, oxygen requires 4 electron, so you multiply manganese by 2 times. So what happened? This will be 2 times, this will also be by 2 times. So 2 2s are 4, potassium hydroxide becomes 4 times. Now balance the number of oxygen and hydrogen. 2 2s are 4, 4 plus 4 8, 8 plus 2 10. So hydrogen 4 hydrogen, this will be 2 times. 2 4s are 8, 8 plus 2 10, 10 oxygen balanced. So when the oxidation of pyrolusite ore to potassium manganate, we are getting a green color mass of potassium manganate. So the potassium manganate which is obtained further converted to potassium permanganate, that can be done either by electrolytic oxidation or oxidized by chlorine or by ozone. Let us find first of all the electrolytic oxidation of potassium manganate. This potassium manganate we are going to take aqueous solution of potassium manganate. So in aqueous medium, potassium manganate splitted into potassium ion and manganate ion. Similarly, water into H plus and OH minus. Now, the oppositely charged ion to be deposited at their electrode. So, at anode, manganate ion is oxidized to permanganate ion. So, where loss of electron takes place, because at anode oxidation reaction occur. So, in this case the green colored manganate is converted into purple color permanganate, and moreover at cathode water is reduced to hydrogen. So, this is the reaction reduction. In this case water, it requires electron, that is converted into H2 and OH minus. For one hydrogen it requires one electron, but we have two hydrogen, so it requires two electron. Therefore, we can have H2 plus OH. By balancing here it makes 2 times, so OH also become 2 times. Now 2 OH minus and this potassium, that is making the solution of potassium hydroxide. So, we are getting the purple colored potassium permanganate, hydrogen, and the potassium hydroxide is present in its solution. This is what electrolytic oxidation of potassium manganate. Suppose if potassium manganate is oxidized by chlorine, we will get potassium permanganate. Once again you balance the reaction, this is plus 6 state, this is plus 7 state. Chlorine 0, it is converted into minus 1. So, chlorine oxidation number decreases, so the process is reduction. Manganese oxidation number increases, the process is oxidation. So, manganese can give 1 electron, but it requires 2 electron because of the presence of 2 chlorine. That's why we are multiplying this is by 2 times. So, we are getting this is 2 KMnO4, this is 2 times. So, everything gets balanced. This is a molecular equation that can even be written in the form of ionic equation, where instead of potassium manganate we will take only manganate ion. This is oxidized by chlorine to form permanganate and chloride ion. Once again equation to be balanced, chlorine needs 2 electron, but manganese can give 1 electron. So, you are multiplying manganate by 2. So, this is also becomes 2 times. So, equation chlorine it becomes 2 times. So, the equation is balanced. The next one, the formation of potassium manganate that can also be converted into potassium permanganate by ozone. So, when potassium manganate is treated with the ozone and water, manganate is converted into permanganate, and where that ozone is reduced to oxygen. So, in this you can balance the reaction. Here we need, this is 2 KMnO4, this is 2 KOH, it becomes 2 times of K2MnO4. Oxygen 2 4s are 8, 8 plus 3 11. So, we have 2 4s are 8, 8 plus 2 10 we have, and balancing the hydrogen we have 2 hydrogen, this is also 2 hydrogen. So, oxygen also balanced, 2 4s are 8, 8 plus 2 10, 10 plus 2 12. This side also 2 4s are 8, 11, 11 plus 1 12. Or you can write it in the form of ionic equation, where instead of potassium we will get the same thing, manganate ion plus ozone plus water, it gives permanganate ion. Without 2 potassium we will get 2 times of OH minus and O2. Potassium permanganate can also be prepared in laboratory. That in this case, any manganese salt like manganese sulfate or manganese chloride that can be oxidized by persulfate ion to form permanganate, sulfate and H plus ion. So, in this case manganese it is in plus 2 state, where it is converted into plus 7 state. So, there is loss of 5 electron. In persulfate, the sulfur it is in plus 6 state, and also in sulfate the sulfur is in plus 6 state. But we said the name of the compound is persulfate. Persulfate structure is S double bond O double bond O O O, S double bond O double bond O. So, in this case all the oxygen atoms are minus 2 except the 2 oxygen which are in minus 1 state because of this peroxide linkage, but sulfur it is in +6 oxidation state. So in the case of persulfate, the oxygen and sulfur which are in -2 do not change their oxidation state, but the peroxide is converted into oxide. So the oxidation takes place due to the presence of peroxide only. So the O-1 has to convert into O-2 like this. So peroxide linkage to be converted into oxide. So this is done by the reduction of gain of electron. Here manganese can give 5 electron. So all those 5 electron to be accepted by persulfate. So we are multiplying this is by 5 times. But one peroxide requires 5 electron. So the 2 peroxide require totally 10 electron, and hence Mn2 plus is multiplied by 2 times. So we have 2 times of MnO4 minus. Here 5 2s are 10 sulfur. So the sulfate it becomes 10 times of sulfate. Number of oxygen hydrogen we have to balance. Here 5 8s are 40, 40 2 4s are 8, 10 4s are 40, 48 oxygen we have, but 40 only here. So we should take water as 8 times. So 8 2s are 16. So hydrogen ion it becomes 16 times. So in this laboratory method, persulfate is reduced to sulfate, where sulfur does not undergo any change. Only the peroxide gets oxidized. Peroxide gets reduced to oxide. That's all the preparation of potassium permanganate. Properties of potassium permanganate. Potassium permanganate actually dark purple colored crystals. When it seems like bulk mass, that would be in the form of a dark, that is like a black color. But at the same time, when individual crystal of potassium permanganate is analyzed, it shows its purple color, or we can say a deep pink color. The aqueous solution of potassium permanganate will be pink in color, and its melting point is 513 Kelvin. Also this potassium permanganate it is isostructural with potassium perchlorate. What do you mean by isostructural? If two of the different compounds having the same structure or same geometry, that is said to be isostructural. Now what is the structure of manganate ion and permanganate ion? Manganate as well as permanganate, both of them have tetrahedral structure. In this case, the manganese is bonded with the 4 oxygen atom, and in permanganate also manganese is bonded with 4 oxygen atom. But in manganate, 2 of the oxygen carries the negative charge. In permanganate, only 1 oxygen that will carry the negative charge. And manganese able to make the back bonding with the oxygen. This is because of the overlapping of d orbital of manganese with p orbital of oxygen. Such overlapping is said to be d pi p pi overlapping. And this is what the structure of permanganate. We can write the isostructural form of a perchlorate ion also. Same way, instead of manganese, chlorine behaves as the central atom. So this is what we are saying isostructural. In manganate, we know the oxidation state of manganese is +7. Similarly, in this case also, the oxidation state of chlorine is +7. And all these cases you may find the tetrahedral structure of manganate, permanganate and perchlorates are given. When we discuss about the magnetic behavior of permanganate and manganate ion, the permanganate is said to be diamagnetic in nature and manganate is said to be paramagnetic in nature. Paramagnetic and diamagnetic that arises out of the presence of unpaired electron in its molecular orbital. So that can be explained upon the molecular orbital theory. That's all the structure of manganate and permanganate ion. The chemical properties of potassium permanganate. Action of heat. So when potassium permanganate on heating, it gives potassium manganate, manganese 4 oxide and oxygen. we have to balance the reaction. In this manganese, it is in +7 state. +7 that changes to +6 and +7 that changes into +4. So here there is gain of 1 electron, and in the other case there is gain of totally 7 to 4, 3 electron. So in total they require 4 electron. But here oxygen -2, here oxygen it goes 0. So 1 oxygen can give 2 electrons. So the 2 oxygen can give 4 electrons. So we can say 2 into 2 electron, that is equal to 4 electron. So the transfer of electron between the manganese and the oxygen being same, it is said to be a self-balanced reaction. So simply balance potassium 2 times. So you can multiply oxygen, you count 4, 4 plus 2 6, 6 plus 2 8. So let us take this is 2 times. So 2 potassium, manganese 2 times, manganese 2 times, oxygen also being balanced. So when there is the transfer of electrons equal, such reactions are said to be self-balanced reaction. Then just like potassium dichromate, potassium permanganate is also a strong oxidizing agent because of its the higher oxidation state of +7. And this oxidizing agent that can be determined, the oxidizing power of permanganate can be determined from their reduction potentials. Suppose when you find the first one, permanganate is reduced to manganate where the E0 value is said to be 0.56 volt. At the same time, when permanganate in acid medium that changes to manganese 4 oxide and water whose E0 value is 1.69 volt. And in the case of permanganate in another acid medium that forms Mn2 plus ion. So here we can say as the strength of acid medium changes, here no acid is present in the first case. The second and third case we have taken the acid medium. So when the strength of acid medium differ and their E0 value also differ. So in their oxidation reactions, the presence of acid medium influences its oxidizing power. So let us balance the reaction. It is +7 in state, receiving 1 electron, it changes into +6. So 1 minus 1 minus 2 minus, this is also 2 minus. And in other case the permanganate it is in +7 state, but in MnO2 that goes +4 state. So 7 to 4 it has to receive 3 electron, and hence we have to balance the rest of hydrogen. 4 oxygen, 2 are here, so we need to take 2 H2O. So out of 2 H2 the H plus becomes 4 times. And in this case where manganese it is in +7 state to +2, so there would be gain of 5 electron. So all those 5 electrons are given, where when we balance the oxygen 4 times oxygen, so this will be 4, 4 2s are 8, so hydrogen will be 8, and the number of negative charges, positive charges will also be balanced. Now when you compare the E0 values of permanganate to manganese 4 oxide or permanganate to manganese ion, where the E0 values are higher than water, the reduction potential of water. So we can say the permanganate can even oxidizes water to oxygen. But it is practically not possible. If at all the reaction to take place, it requires either the presence of manganese ion or at the high temperature only the reaction that can be carried out. But at room temperature, the reaction will be very slow. Let us discuss potassium permanganate. How does it oxidizes the other species in an acid medium? So in an acid medium, actually permanganate is reduced to Mn2 plus ion, that is manganese ion, where it requires 5 electron because of 7 to 2. So the reacting species whichever being oxidized has to give 5 electron to reduce permanganate to manganese. Now let us see the first of all oxidation of ferrous. Ferrous is oxidized to ferric ion, and the ferrous to ferric that can give only one electron, so simply you can multiply. This is the ferrous ion 5 times and Fe3 plus also 5 times, because manganate, permanganate, it requires only 5 electron. So we are multiplying ferrous with 5, where Mn plus 7 that changes into Mn2 plus, and the 4 oxygen that it is left as water, so 4 2s are 8, it requires 8H plus. And the next one, this permanganate that can oxidize as oxalate ion into carbon dioxide. Oxalate ion actually oxalic acid or any salt of oxalate, COO minus, COO minus. In this case, both carbon atom are in +3 state, but in carbon dioxide the C is in +4 state. So the carbon +3 to +4, it can give 1 electron, but how many carbon I have? 2 carbon. 2 carbon will give 2 electron. So but manganese it requires 5 electron. What we have to do? The 2 and 5 we can cross multiply. This is you multiply by 5 times. This is you multiply by 2 times. So manganese requires 10 electron. Same, the 5 2s are 10, carbon can give 10 electron, and hence we are having 2 Mn2 plus and 5 2s are 1, 2, 2 5s are 10, so 10 times of carbon dioxide, and the hydrogen 2 4s are 8, so the water molecule will be 8 times, where the H2 it becomes 16H plus because of 8 2s are 16. The next one, oxidation of nitrite to nitrate. In nitrite, the oxidation state of nitrogen is +3, and in the case of nitrate it is +5. So nitrite upon oxidation of nitrate it can give 2 electron. So but manganese requires 5 electron. So do the cross multiplication. This NO2 multiplied by 2 times and permanganate is multiplied by 2 times. So 5 NO2, 5 times NO3. Now balance the number of oxygen. 5 2s are 10, 2 4s are 8. 10, 18, here 5 3s are 15, so 3 molecules of water, 15 plus 3, 18. So now number of hydrogen will be 6 times. The next one, that permanganate can oxidize as iodide to iodine. So in this case also iodide to iodine that can give 1 electron, but the presence of iodine that makes 2 electron, but manganese requires 5 electrons. So once again cross multiply, this is 5 times and permanganate by 2 times. So here 2 Mn2 plus, 5 2s are 10, 10 I minus. Number of oxygen 2 4s are 8, 8 H2O, 8 2s are 16. So this is 16 H plus. Then just like nitrite to nitrate, this permanganate can oxidize as sulfite to sulfate. In sulfite, the oxidation state of sulfur is +4, and in sulfate, the oxidation state of sulfur is +6. So once again, there is the difference of 2 electron, cross multiply. So sulfite multiplied by 5 times, and permanganate multiplied by 2 times. So correspondingly, this is 2 times, and sulfite to sulfate, this is also 5 times. Now balance the number of oxygen. 5 3s are 15, 2 4s are 8, 15 plus 8, 23 here. Here 5 4s are 20 only. So the difference of oxygen 3. So this is multiplied by 3 times, and number of hydrogen 3 2s are 6 times. So that's all. Similarly, potassium permanganate can oxidize sulfide to sulfur. Sulfide, in this the oxidation state of sulfide is 2 minus, and in sulfur that goes 0. Once again sulfur can give how many electron? 2 electron, but manganese requires 5 electron. Cross multiply, this is by 2 times, this is by 5 times, and it is also 5 times, and 2 Mn, this is 2 times. Number of oxygen 2 4s are 8, it becomes 8 H2O, and the hydrogen 8 2s are 16, 16 H plus. So these are the reactions which are carried out in acid medium, in which the permanganate is reduced to a manganese ion, but the reaction to be carried out in strong acid medium. That's all the behavior of oxidizing nature of potassium permanganate in acid medium. What is Bayes reagent? Bayes reagent already we discussed in organic chemistry chapter hydrocarbon. So in this, the Bayes reagent is a cold dilute alkaline solution of potassium permanganate is said to be Bayes reagent, and this Bayes reagent that can be used to identify the presence of unsaturation in organic compound. So where the alkene that can decolorizes the Bayes reagent, and we also studied the ethene on decolorization of potassium permanganate, that means Bayes reagent we will get ethylene glycol. This is we discussed in our hydrocarbon chapter. So ethylene that is converted into ethylene glycol because of the Bayes reagent. So where the decolorization of potassium permanganate takes place, and hence this is said to be the test for unsaturation. In the oxidation reactions of potassium permanganate, we used to prefer the sulfuric acid to provide their acidic medium. But in place of sulfuric acid, the hydrochloric acid cannot be used. This is why, because the potassium permanganate can easily oxidizes hydrochloric acid to chlorine. See, potassium permanganate with the hydrochloric acid, potassium to potassium chloride, manganese to manganese chloride, where the HCl is oxidized to chlorine. You can identify the change in oxidation state of chlorine and manganate. This is -1, this is 0. Permanganate, it is in +7 and here it is in +2. So +7 to +2 there is there is gain of 5 electron. And chloride -1 to 0, oxidation number increases. So there is loss of 1 electron. How many chlorine I have? 2. So I should multiply this is by 2. So chlorine can give 2 electron, but manganese it requires 5 electron. So multiply this is by 5 times, this is by 2 times, just for balancing. So it is multiplied by 5 times, this is multiplied by 2 times. So 10, transfer of electron becomes equal. Now balance the rest of the one, 2 potassium chloride, 2 manganese chloride, 2 4s are 8 oxygen. So there would be 8 H2O and 8 hydrogen. HCl will be 16 HCl. Number of chlorine 16. 2 2s are 4, 4 plus 2 6, 5 2s are 10, 10 plus 6 16. So in such cases, suppose if at all the question is asked in place of sulfuric acid, why don't you make use of hydrochloric acid to provide the acid medium? We have to say potassium permanganate being strong oxidizing agent that oxidizes hydrochloric acid to chlorine. Potassium permanganate as an oxidizing agent in neutral or faintly alkaline medium. So in such cases where permanganate ion is reduced to manganese 4 oxide. So the oxidation state of permanganate +7 to +4 that decreases. So it requires 3 electron, and in this case 4 oxygen are there, MnO2 plus 2 H2O, therefore we have 4 H plus ion. So the equation is balanced. So in such medium where permanganate ion is reduced to manganese, is 4 oxide is formed, but in strong acid medium Mn2 plus manganese ion is formed. Here manganese 4 oxides are formed. This is we have to note down. The next one, how the iodide is oxidized to iodate. In acid medium, iodide is oxidized to iodine, but in faintly alkaline medium, iodide is oxidized to iodate ion. So let us find. Here the balancing, it depends upon the charges only. So I didn't mention whether water or H plus is required or not. Upon balancing only, we have to count and identify whether the OH minus or water to be added. Let us find the first one. In this case, manganese, it is in plus 7 state. Here it is in plus 4 state. Iodide minus. Here 3 2s are minus 6. Minus 6 equal to minus 1 or x equal to plus 5. So in this case, iodine, it is in plus 5 state. So manganese, it requires 3 electron, but iodide can give how many electron? 6 electron. So you can identify here gain of 3 electron. Here iodide to iodate ion minus 1 to plus 5, there is loss of 6 electron. So here it takes place 6 electron. So what we have to do? All the 6 electron to be gained by permanganate ion only. So this is multiplied by 2 times and this is also multiplied by 2 times because it has to take away the 6 electron. Now balance the number of charges. 2 minus totally 3 negative charges. And here I have only 1 negative charge. Here I have only 1 negative charge. Left side 3 minus but right side minus 1. So I have to make this to the right side 3 minus. That's why we are going to add 2 times of OH minus ion. Now you balance the charges 2 minus, minus 3 minus, minus 2 minus 3 minus. So the equation balanced. Corresponding to the addition of hydroxyl ion, we have to add the same number of water molecule also. So balance the oxygen, 2 4s are 8. 2 2s are 4, 4 plus 3 7, 7 plus 2 9 it comes. So we should add a molecule of water over here. So now the number of oxygen balanced, number of hydrogen also balanced. So oxidation of thiosulfate to sulfate. In this case we have to identify what is the oxidation state of sulfur in thiosulfate. So S2O3 2 minus 2x plus 3 into minus 2 equal to minus 2 or it is equal to 2x minus 2 plus 6 equal to plus 4 or x equal to plus 2. So in the sulfur it is in plus 2 state while in sulfate the sulfur it is in plus 6 state. So we may find plus 2 to plus 6 there is loss of 4 electron. But how many sulfur we have? 2 sulfur. So that makes into 8 electron. So all these 8 electron must be received by MnO2. So it is multiplied by 8. But manganese plus 7 to plus 4 state. So that is there is gain of 3 electron and this 3 is multiplied with thiosulfate. 3 2s are 6 sulfate and 8 MnO4 minus. Now balance the charges. 8 minus 3 2s are 6 minus 8 plus 6 14 minus. Here only 6 2s are 12 minus. So add 2 times of OH minus. Correspondingly balance the number of water molecule hydrogen. So it is H2O. Now number of oxygen 8 4s are 32. 3 3s are 9. 9 plus 1 10. Now 10 plus 32 42. 8 2s are 16. 6 4s are 24, 34, 34, 42, 42 plus 46. So by comparing the number of oxygen on both sides, oxygen atom will also be balanced. The next one, oxidation of manganese ion. The manganese salts are once again that is reduced to MnO2 only. So permanganate ion that oxidizes Mn2 plus 2 MnO2. So we have to find here plus 7 2 plus 4. So that is gain of 3 electron. But here Mn2 plus 2 Mn4 plus that is loss of 2 electron. So here 3 electron, there 2 electron. So we have to cross multiply. This is to be multiplied by 3. This is to be multiplied by 2. So that makes 3 plus 2, 5. So 5 times MnO2 is formed. Now balance the charges. 2 minus 3 2s are 6. 6 2 minus, that is equal to 4 minus. So to balance the neutral, we have to add 3 2s are 6, 2 minus 4 plus is there. So to balance the positive charges, we should add 4 times of OH minus ion. So to balance the negative charges, 4 times of OH minus added to the reactant side, then only the charge will be cancelled, and the product side the corresponding water will be formed. How many water? 2 4s are 8, 4 hydrogen, so there will be 2 molecules of water. Oxygen 2 4s are 8, 8 plus 4 12, 5 2s are 10, 10 plus 2 12. So oxygen also be balanced. That's all. The oxidizing property of potassium permanganate. Potassium permanganate can alone exhibit its oxidizing property both in acid medium as well as in faintly alkaline or neutral medium. In acid medium, that reduces to Mn2 plus ion, but in faintly alkaline medium, permanganate is reduced to manganese 4 oxides. Now what are the uses of potassium permanganate? Uses of potassium permanganate. We know very well potassium permanganate is such a strong oxidizing agent. Because of its oxidizing property, that can be used as an oxidizing agent in most of the organic reactions, and it can also be used as a bleaching agent that can decolorize the wool or cotton, etc. The textile fibers can be bleached. The next one, that can also be used as a decolorizing agent that can decolorize the oils or some other food material. So because of the oxidizing property of permanganate, we can make use of it as an oxidizing agent, bleaching agent as well as decolorizing agent. Okay students, that's all. The preparation and properties of potassium permanganate. Let us close our today's session, and we will continue the same chapter in the following sessions. Until then, bye bye.